Question 11 SCP Inheritance. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of topics including cloud, networking, and security. Also hit the bell icon to get notified of new videos. Let us begin part 2 with question 11. A company uses AWS organizations with a hierarchical structure. The root has an SCP that allows all actions. An organizational unit called production has an SCP that denies EC2: terminate instances. An account in the production OU has an IAM user with administrator access policy. Can the user terminate EC2 instances? Option A states, yes, because administrator access grants full permissions to all services. Option B states, yes, because the root SCP allows all actions which overrides the OU SCP. Option C states, no, because service control policies at any level in the hierarchy can deny actions. Option D states, no, because IAM policies cannot override organization policies. Let us examine the incorrect answers first. Option A is incorrect because administrator access is an identity-based policy that grants permissions, but SCPs set the maximum permissions allowed in an account. Even with administrator access, actions denied by SCPs cannot be performed. Administrator access only grants what SCPs allow. Option B is incorrect because secure copy protocols do not work through overrides. They work through intersection. All secure copy protocols in the path from the root to the account must allow an action for it to be permitted. The root allowing all actions does not override a deny at the OU level. Option D is incorrect in its reasoning. While the conclusion is correct that the user cannot terminate instances, the explanation is misleading. It is not that IAM policies cannot override organization policies in general. Rather, effective permissions are the intersection of what SCPs allow and what IAM policies grant. SCPs define the ceiling, not something to be overridden. The correct answer is option C. Service control policies work through inheritance in the organizational hierarchy. For an action to be allowed, it must be permitted by SCPs at every level from the root down to the account. The root SCP allows all actions, but the production OU SCP denies EC2 terminate instances. Since this deny is in the path to the account, the action is blocked for all identities in that account, regardless of their IAM permissions. SCPs set the maximum available permissions, and any deny in the hierarchy restricts those maximums. This is a critical concept for organizations implementing guardrails across multiple accounts. Question 12 IAM Policy Variables. Moving to question 12. A security engineer wants to create a policy that allows IAM users to manage only their own access keys and MFA devices. The engineer uses the policy variable $, open curly brace AWS : username close curly brace in the resource ARN. The policy allows IAM : create access key, IAM : delete access key, and IAM : create virtual MFA device on resource ARN : AWS : IAM : 123456789012 user $, open curly brace AWS : username close curly brace. Users report they can manage access keys but cannot create MFA devices. What is wrong? Option A states, the MFA device actions require a different resource type ARN with MFA instead of user. Option B states, the AWS username variable is not supported for MFA device operations. Option C states, users need IAM enable MFA device permission in addition to create virtual MFA device. Option D states, the policy needs to use $ open curly brace AWS : user ID close curly brace instead of $ open curly brace AWS : username close curly brace. Let us analyze the incorrect options. Option B is incorrect because AWS username is supported for MFA operations. Policy variables work across IAM actions as long as the variable is valid for the context. The username variable resolves to the IAM user's name in all IAM API calls. Option C is incorrect because while enable MFA device is indeed a separate permission needed to associate an MFA device with a user, the question specifically states users cannot create MFA devices. The create virtual MFA device action creates the virtual MFA device object, and enable MFA device associates it with a user. These are different issues, and the question focuses on creation. Option D is incorrect because AWS user ID is the unique identifier for the principal, not the username. For IAM users, the user ID is a unique ID like AIDAEXAMPLEID, not the username. Using user ID in the resource ARN would not match the user resource which is identified by name. The correct answer is option A. Virtual multi-factor authentication devices in IAM have a different resource type than users. While access keys are associated with the user resource type, multi-factor authentication devices have their own resource type. The correct ARN for a virtual multi-factor authentication device is ARN:\IAM:1234567890012:MFA/$ open curly brace AWS:username close curly brace, not ARN:\IAM:1234567890012:user/$ open curly brace AWS:username close curly brace. The policy needs two resource statements. One for user resources for access key operations, and one for MFA resources for multi-factor authentication device operations. This is a common mistake when creating self-management policies. Question 13. NotAction versus deny. Let us proceed to question 13. A security engineer creates a policy to allow a user to perform any action except deleting S3 buckets. The engineer uses effect allow with NotAction S3 delete bucket and resource wildcard. After applying the policy, the user discovers they can delete S3 buckets. What is wrong with this policy? Option A states NotAction with allow grants permissions for all other actions but does not deny the specified action. Option B states the S3 delete bucket action requires an explicit resource ARN, not a wildcard. Option C states NotAction only works with effect deny, not effect allow. Option D states the user must have another policy that is allowing S3 delete bucket. Let us examine the incorrect answers. Option B is incorrect because wildcard resources are valid for S3:delete bucket. The resource specification is not the issue here. You can use a wildcard to apply the policy to all buckets, or specify individual bucket ARNs. Option C is incorrect because NotAction works with both allow and deny effects. The behavior is different for each, but both are syntactically valid and have legitimate use cases. NotAction with allow is commonly used to grant broad permissions while explicitly not granting certain sensitive actions. Option D is incorrect because even if another policy allows S3 delete bucket, that would be expected behavior, not an error. However, the question implies the engineer expected the user to not be able to delete buckets based on this single policy, which reveals a misunderstanding of how NotAction works with allow. The correct answer is option A. This is a critical distinction that confuses many people. NotAction with effect allow means allow all actions except the ones listed. It does not deny those actions. It simply does not grant them. If the user has another policy that grants S3:delete bucket, or if the bucket has a resource policy allowing it, the user can still perform that action. To actually prevent an action, you must use an explicit deny statement. The correct approach would be to have one statement with effect allow an action wildcard to grant all permissions, and a separate statement with effect deny an action S3:delete bucket to explicitly block that action. Question 14. MFA condition enforcement. Moving on to question 14. A company policy requires MFA for all sensitive operations. A security engineer creates a policy with effect deny, action wildcard, resource wildcard, and condition bool if exists with AWS multi-factor auth present equals false. However, API calls made with long-term access keys are not being denied even without MFA. What is causing this issue? Option A states, the BoolIfExists operator allows the action when the condition key is missing from the request. Option B states, long-term access keys cannot be used with MFA authentication. Option C states, the policy should use AWS multi-factor auth age instead of multi-factor auth present. Option D states the deny effect does not work with condition operators. Let us analyze the incorrect options. Option B is incorrect because long-term access keys can be used with MFA. When you use the getSessionToken API with an MFA token code, you receive temporary credentials that have MFA authentication. These credentials can then be used for API calls that require MFA. So MFA is possible with access keys through this process. Option C is incorrect because AWS multi-factor auth age checks how long ago the MFA authentication occurred in seconds, not whether MFA is present. While this can be useful for requiring recent MFA, it would not solve the problem of missing MFA context entirely. Multi-factor auth present is the correct key for checking if MFA was used. Option D is incorrect because deny effect works perfectly well with condition operators. You can and should use conditions to make denies more specific. For example, denying actions only when MFA is not present, or only from certain IP ranges. The correct answer is option A. The BoolIfExists operator has specific behavior when the condition key does not exist in the request context. When using long-term access keys directly without going through getSessionToken with MFA, the AWS multi-factor auth present key is not present in the request at all. BoolIfExists evaluates to true when the key does not exist, meaning the condition is not met and the deny does not apply. To enforce MFA properly, you should use the bool operator instead, which treats a missing key as not matching the condition. Alternatively, use null condition to check if the key exists. The correct approach is to use bool with AWS multi-factor auth present equals false or use null with AWS multi-factor auth present equals true, which catches both cases. Question 15. Resource policy same account access. Let us continue with question 15. An IAM user in account A needs to invoke a Lambda function in the same account. The user has no identity-based policy granting Lambda invoke function. However, the Lambda function has a resource-based policy that allows the user's ARN to invoke it. Can the user invoke the Lambda function? Option A states, no, because identity-based policies are always required for IAM users to perform actions A. Option B states, yes, because resource-based policies can grant access to same account principals. Option C states, no, because Lambda resource policies only work for cross-account access. Option D states, yes, but only if the user also has Lambda get function permission. Let us examine the incorrect answers. Option A is incorrect because it states a rule that does not exist in AWS. Identity-based policies are not always required. Within the same account, either an identity-based policy or a resource-based policy can grant access. This is different from cross-account access where both are typically required. Option C is incorrect because Lambda resource policies work for both same account and cross-account access. Resource policies can specify any principal, including IAM users and roles in the same account. They are commonly used to allow other AWS services to invoke Lambda functions. Option D is incorrect because Lambda get function is a separate permission for retrieving function configuration and code. It is not required for invoking a function. Invoke function and get function are independent actions with separate permissions. The correct answer is option B. This is an important distinction between same account and cross-account access. Within the same AWS account, if a resource-based policy grants access to a principal, that is sufficient for the principal to access the resource, even without an identity-based policy granting the permission. This is because both the resource owner and the identity owner are the same account. For cross-account access, both sides typically need to allow the access because there are two different account owners involved. This same account behavior applies to Lambda, S3, SQS, SNS, and other services that support resource-based policies. Question 16. Confused deputy prevention. Now we will examine question 16. A third-party SaaS application needs to assume a role in a customer's AWS account to access their S3 data. The customer is concerned about the confused deputy problem where other customers of the SaaS provider might access their data. What should the customer require in the roles trust policy? Option A states a condition checking that AWS:source account matches the customer's account ID. Option B states a condition checking that STS external ID matches a secret value shared with the SaaS provider. Option C states a condition checking that AWS principal organization ID matches the customer's organization ID. Option D states a condition limiting the source IP addresses to the SaaS provider's known IP range. Let us analyze the incorrect options. Option A is incorrect because AWS:/source account is used when an AWS service assumes a role on behalf of a resource, such as S3 replication or CloudTrail. In this scenario, the SaaS application is directly assuming the role, not an AWS service. The source account would be the SaaS provider's account, which does not help distinguish between different customers. Option C is incorrect because AWS principal organization ID checks if the assuming principal belongs to a specific AWS organization. The SaaS provider's account is not in the customer's organization, so this would not work. Even if it did, it would not distinguish between the SaaS provider's different customers. Option D is incorrect because IP-based restrictions are not reliable for this use case. The SaaS provider likely uses the same IP addresses for all customer integrations, so this would not prevent one customer's credentials from being used for another. It also creates operational challenges when IP addresses change. The correct answer is option B. The external ID is specifically designed to prevent the confused deputy problem in cross-account role assumption scenarios. The customer generates a unique secret external ID and shares it only with the SaaS provider for their specific integration. The trust policy condition requires this external ID to be present when assuming the role. Even if the SaaS provider is tricked into assuming the role for a malicious purpose, they would use the wrong external ID and the assumption would fail. The external ID acts as a shared secret that proves the request is for the intended customer. This is an AWS recommended best practice for third-party integrations. Question 17 IAM Access Analyzer Findings. Let us move to question 17. A security engineer runs IAM Access Analyzer and finds that an S3 bucket is accessible from an external AWS account. The engineer wants to ensure this is intentional. Upon investigation, the bucket policy allows access to an account ID that belongs to a partner company. What should the engineer do? Option A states, delete the bucket policy statement to remove external access immediately. Option B states, archive the finding after confirming the access is intended and documented. Option C states, create an SCP to deny S3 access from external accounts C. Option D states, enable S3 block public access to prevent all external access. Let us examine the incorrect answers. Option A is incorrect because deleting the bucket policy without understanding the business requirement could break the partner integration. Security engineers should investigate findings, not immediately remediate them without context. The access might be critical for business operations. Option C is incorrect because secure copy protocols apply to principals in your own organization, not to external accounts accessing your resources. You cannot use a secure copy protocol to block access from an external account. Secure copy protocols control what identities in your organization can do, not what external identities can do to your resources. Option D is incorrect because S3 block public access prevents anonymous public access, not cross-account access to specific principals. Access granted to a specific AWS account ID is not considered public access. Blocked public access would not affect this finding. The correct answer is option B. IAM Access Analyzer is designed to identify resource policies that grant access outside your zone of trust. However, not all external access is unintended. When you confirm that access is intentional and properly documented, you should archive the finding. Archiving tells Access Analyzer that you have reviewed and approved this access, and it will not generate new findings for the same access. The engineer should document the business justification, ensure the partner relationship is current, and then archive the finding. Access Analyzer will continue to monitor for new external access and generate findings for any changes. Question 18. Wildcard principles in resource policies. Proceeding to question 18. A developer creates an SQSQ policy with principal set to wildcard and a condition that the AWS source ARN must match a specific SNS topic ARN. The developer believes this is secure because only the SNS topic can send messages. A security reviewer raises a concern. What is the potential security issue? Option A states, the wildcard principle allows anyone to delete the queue, not just send messages. Option B states, the AWS source ARN condition only works for AWS service principals, not wildcard. Option C states, any principal who knows the SNS topic ARN can spoof it in their request. Option D states, the policy should use a AWS:source account instead of a AWS:source ARN for better security. Let us analyze the incorrect options. Option A is incorrect because the concern would be valid if the policy allowed all SQS actions, but typically such policies are scoped to SQS:"send message. Even so, this is not the primary security concern the reviewer would raise about the combination of wildcard principle and source ARN condition. Option B is incorrect because AWS source ARN works when AWS services make requests on behalf of resources, regardless of the principal specification. The condition evaluates the source resource that triggered the service to make the call. This works with wildcard principles. Option D is incorrect because AWS source account is less specific than AWS source ARN. Using source account would allow any SNS topic in the specified account to send messages, which is less secure. Source ARN restricts to a specific resource and is the better choice when you know exactly which resource should have access. The correct answer is option C. This is actually a misconception that the security reviewer might have. In reality, the AWS source ARN condition is secure when used with AWS services. The source ARN is populated by the AWS service making the call, not by the external caller. When SNS publishes to SQS, SNS populates the source ARN with its own topic ARN. An external user cannot spoof this because they do not control what SNS puts in the request context. However, if this were a different condition key that callers can control, spoofing would be a concern. The reviewer should be educated that service-populated condition keys like source ARN are secure. Question 19. Policy evaluation for KMS. Let us continue with question 19. An IAM user has an identity-based policy allowing KMS:"encrypt on all KMS keys. The user tries to encrypt data using a specific KMS key but receives an access denied error. The KMS key policy only allows the root account principal. What is happening? Option A states, key management service keys require both key policy and identity-based policy to allow access by default. Option B states, The KMS:"encrypt" action also requires KMS:"generate data key permission." Option C states KMS keys cannot be used for encryption without first enabling automatic key rotation. Option D states the user needs key management service. Describe key permission before using any key management service operations. Let us examine the incorrect answers. Option B is incorrect because KMS:"encrypt" and KMS:"generate data key are independent operations. Encrypt is used to encrypt small amounts of data directly with the CMK, while generate data key is used to get a data key for envelope encryption. You do not need both for basic encryption. Option C is incorrect because key rotation is unrelated to key usage permissions. Key rotation is a security practice for regularly replacing the backing key material, but it has no effect on who can use the key. A key can be used regardless of rotation settings. Option D is incorrect because key management service describe key is used to get metadata about a key, not to use it for cryptographic operations. While it is often granted together with other permissions for convenience, it is not a prerequisite for key management service encrypt. The correct answer is option A. Key management service has a unique permission model compared to most AWS services. By default, key management service key policies do not grant permissions to IAM entities in the account. They must explicitly enable IAM policies to be used. The key policy statement that allows the root account principal is the mechanism that enables IAM policies. This statement says that IAM policies in the account can grant permissions on this key. Without this enabling statement, or without an explicit grant to the user in the key policy, identity-based policies alone cannot grant access to the key. This is a critical security feature that gives key administrators control over who can use IAM to manage access. The user needs either a key policy statement granting them access or the key policy must enable IAM policies by allowing the root principal. Question 20. Pass role permission. Finally, let us examine question 20. A developer needs to launch EC2 instances with an IAM role that allows the instances to access DynamoDB. The developer has EC2:run instances permission and the role exists with proper DynamoDB permissions. When launching the instance with the role, the developer receives an access denied error. What permission is the developer missing? Option A states the developer needs DynamoDB: permissions to pass a role with DynamoDB access. Option B states the developer needs IAM: pass role permission for the specific role ARN. Option C states the developer needs IAM attach role policy permission to use roles with instances. Option D states the developer needs EC2:associate IAM instance profile permission. Let us analyze the incorrect options. Option A is incorrect because the developer does not need the same permissions as the role they are passing. This would be impractical and would negate the benefits of using roles. A developer can pass a role with permissions they do not have themselves, as long as they have permission to pass that specific role. Option C is incorrect because IAM attach role policy is used to attach a policy to a role, not to associate a role with a resource. This is a different operation used during role creation or modification, not during resource launch. Option D is incorrect because while EC2:associate IAM instance profile might seem relevant, the Run Instances API includes the ability to specify an instance profile. Associate IAM instance profile is used to attach a profile to an already running instance. The developer has Run Instances permission, which covers launching with a profile. The correct answer is option B. The IAM pass role permission is a critical security control that determines who can associate IAM roles with AWS resources. When you launch an EC2 instance with a role, create a Lambda function with an execution role, or configure any service that assumes a role, you need IAM pass role on that specific role. This prevents privilege escalation where a user could pass a highly privileged role to a resource they control and then use that resource to perform actions beyond their own permissions. The pass role permission should be scoped to specific role ARNs that the developer is authorized to use, not granted as a wildcard. This is a commonly tested concept on the Security Specialty exam because it is fundamental to preventing privilege escalation. Thank you for your attendance. Please consider subscribing to the channel and liking this video.